During the previous lecture and the previous video clip for this week, we covered generalities about neural networks. Now in this video clip we are going to cover a very quick example that I hope is going to help you to understand the main idea of this method. Students shall to understand the methods that we have covered for the estimation techniques. The idea, the intuition about the methods is very important for the selection of the best forecast and to understand what you are doing when forecasting. The mathematical explanation is as well very important, but the intuition I think is even more important than the mathematical expression. So let's go to my full desktop. So we are going to analyze again the chapter 9 in the textbook. First of all, these are the steps that you need to follow in order to prepare yourself to forecast using neural networks. Number 1, choosing the predictors. Number 2, pre-process the variables or the predictors. Yes. Number 3, specify what is the network architecture. We covered that during the previous video. Number 4, we need to specify the algorithm parameters. The algorithm parameters are going to help us to calculate the weights, to calculate the hidden nodes. And if you are using neural networks, and this is actually very interesting, if you are using neural networks for binary forecast, so you have now logistic regression and as well neural networks, for instance, to forecast whether to buy or not certain share, then you need to determine the cutoff value. During my previous video, for instance, we say that the cutoff value for the returns of a asset was around 5% or something like that. Yes, so you can determine what is the cutoff in order to determine what is 0 and what is 1. Okay, so the step number 1 is to the choice of predictors. In neural networks, it's very important the choice of what are the predictors and also their quality. So it's very important to have very clean data. So reviewing the variables that you are going to include in the model is very important because the model is actually very sensitive to data that is erroneous. One of the second things in the pre-processing, we are following these steps, is that we need to change or transform the variables. Particularly the normal variables do not work very well. So when we, for instance, have logarithmic or skewed variables, we need to deseasonalize or detrend the data. We did this previously by making averages, if you remember. Yes, we detrend the data by doing actually sometimes 2 averages, so the previous month average and then the 12-month average, and in doing that we smooth the data set, and we can use logs as well to try to minimize the problem. And these methods are actually a little bit controversial, the trending and deseasonalizing the data. So what we can do is as well to scale the data. So we can scale the data from 0 to 1 or from -1 to 1. When we use 0 to 1, we use a logistic scale, and when we change the scale of our data, from -1 to 1, that is called tan. For binary forecast, we create one dummy variable, and I think that we can do that using any chair. Yes. So you just select what is the cutoff for the dummy equals 0, and what is going to be the values or the returns when your dummy shall be 1. So you choose 3% or above 3%, I will say is 1, and below 3% 0. Here we have an example using ridership on Amtrak trains. So this is a US rail company, and we have some data from 1991 to 2004. The Excel file, you can find it actually you can find it in your folder datasets in Blackboard. The Amstrad predictor choice and pre-processing. So we need to account for seasonality. We create 12 lags. We create 11 dummy variables, and we deseasonalize the time series using the first average. Yes. So an example of this is here. As you can see, this is lag number 1, so it's the same data but lagging one period of time. Then we have lag 2, lag 3, lag up until lag 12. The validation period, the selected validation period, is going to be 12 months in this case. Afterwards, we pass to the number 3 after manipulating the data and removing the seasonality. So we can specify the network architecture. The most popular number of hidden layers is just a single hidden layer. When we add more layers, we add more complexity, but the problem is that we increase the chances of overfitting. That means that our forecast is always just to be useful just for that particular time series. So the number of output nodes as well for classification, one node per class. In binary case can also be only one node. And for numerical prediction, they use 1. So if, as we want to forecast, for instance, one period ahead, we can use just one node. So this is the way in which our example looks. So we have YT and all the lags, the 12 lags that we had in our data previously in the previous slide. Here we have the hidden layer. As you can see, all the interactions are converging into this hidden layer, and also we have interactions between these nodes in order to calculate the output layer, our forecast. We also need to specify the algorithm parameters. One of the parameters that we need to specify is the learning rate. The low values of the learning rate arrive more slowly to the best solution. So low values downweight the new information from errors at each iteration. This means that a low value or low learning rate slows the learning, but reduces the tendency to overfit to local structure. The momentum is high values keep parameters changing in the same direction as previous iteration. And this helps avoid overfitting to local structure but also slows the learning. So when we keep the momentum low again, it slows the learning. So the number 5 is to determine the cutoff value, especially for binary forecast. The cutoff is on the probability to obtain binary classification. The tendency of probabilities is to cluster around 0.5, and we use the validation period to choose the cutoff. So here we have the example using neural networks. Here we have the data, and you can see here the forecast that is resulting from neural networks. In gray, the actual value, neural networks is the black line, that is the forecast. As you can see, it's actually very interesting the way in which it moves, very similar to the actual data. In the next video then we are going to cover a practical example using R.